and welcome to Inspiral Out Loud, where Mars and I are chatting about energy today and looking at how it is and how it could be potentially done a bit better. So we're currently using standard electricity in houses, and a lot of people, such as myself, are actually quite sensitive to dirty electricity, to EMFs, to things like that in the environment. Maz, do you know much about, say, dirty electricity and the kinds of electricity that we're using and why they're damaging?
Yeah, the problem with household power is not so much the power itself. To kind of preface all of this, when you've got electrical current running through any sort of wire, you create a certain amount of electromagnetic field around the wire. And depending on how much current is running through that wire, you get larger fields. Now, when you've got electrical wiring running through your home, I won't get into too much technicality, but basically if it's a straight wire, the field is quite minimal. If it's coiled up, it amplifies the field. So wiring in the house isn't really so much of a problem for us generally, as long as you don't have things like directly next to your head while you're sleeping and that sort of thing. But the problem becomes when the power is what they call dirty, which is, if you think of a alternating current which goes through all household wiring, it means that a field of electricity is moving forward and backwards. And in Australia, it's at 50 hertz, which is 50 cycles, which is 50 times a second. That doesn't produce a massive field around the wire. But when you start having changing or transient smaller signals interacting with the wiring in the house, it starts producing tiny little ripples in the wave coming out. The field coming off the wiring, and those little ripples are what is known as dirty power, and that's what affects us. It's the same reason why Wi-Fi, mobile signals, and other various sorts of communication technologies interfere with our cells. It's not so much the carrier or the base cycle, it's the little ripples that cause a lot of the problems. So there are some technologies that you can use to minimize that to some extent.
So by those technologies, are you talking about things like I've seen devices that you say plug into the wall that are supposed to, I don't know what you'd even call it, equalize or neutralize those spikes? Is that what you mean by the technology that's available?
Yeah, so you can do it either per PowerPoint, or you can actually buy special devices that are a bit more expensive that you can essentially put between the fuse box in your house and the rest of the entire household. Those are considerably more expensive. But if you're particularly sensitive, well, it's worth spending the money to preserve your health. I mean, what better way to spend your money than to preserve your health? That's all you've got, really.
Yeah. Now, so the technology that we're using currently in order to send electricity into houses and utilize it, has that changed at all? And was it any better, or have we always had these issues with it?
Generally, with the introduction of mobile towers and Wi-Fi units and all of these kind of devices, that has increased the problem. But generally speaking, it depends on how the infrastructure is created in various states. Some places have pretty clean power, some places have incredibly dirty power and unregulated power. In Australia, we have a lot of problems with very severe spiking in the power supply. So That's not so much to do with dirty power, that's more to do with unregulated power, but that causes its own problems. A lot of electronic devices get damaged if that happens frequently enough. So sometimes you could, you know, we see on our standard plug in the wall devices that it says 240 volts, and if you measure the output out of the wall, sometimes that can spike up to nearly 500 volts, depending on what's going on, either through the transmission of the electricity or the actual production.
Right, and I had thought that, say, using solar power would have helped to address that, but in fact, I've heard from a friend area that actually in solar powered houses that the dirty electricity is running rife. Do you know about that?
Not a lot about it. I would suspect if that's occurring, it might be one of two things. It could either be that the interaction between the power produced by the solar cells and then going through the inverters, or converters, might be somehow interacting with the cycle coming in from the grid, and that the interaction between those two might be causing ripples, which is dirty power. Could also be cheap converters from the solar from direct current, which is what solar cells produce, into alternating current, which is what comes out of the wall. I'm sure if that's either of those two cases, there should be some way to regulate that with better designed converters.
Yeah, and you've also mentioned with solar previously that one of the main issues currently is how to store the energy itself, and that the amount of resources required to even generate that infrastructure at the end of the day isn't a whole lot better to what we've got already. Would you like to speak to that?
The problem with a lot of alternative technologies, and batteries is a big problem, is how expensive it is going to be to produce batteries that can carry the amount of store the amount of power that we need to make that a viable option when dealing with renewable energies like solar in particular for your nighttime use. The problem with batteries is they all use, all the rechargeable type of batteries all use toxic compounds one way or another. Doesn't matter whether it's the standard car battery, which is lead acid, when you've always got disposal problems with lead when the batteries fail, or you've got all of the expense of the more modern batteries like the types that you'll see in mobile phones and other portable devices. They all use lithium largely because that's sort of the most efficient and the greatest storage capacity which you need. And lithium mining is a real serious environmental issue. There's also a lot of these renewable technologies are a little bit of a false promise because they fail to address the problem that in order to get those raw materials to produce the renewable technologies, they all require fossil fuels anyway, because you've got mining, transportation, etc. All of those are the hidden costs behind the mining of lithium, the processing of it. All of that largely comes off our coal-powered electricity to run that whole thing, or oil to run the machine, the trucks and everything else that goes on. And it's not just the cost benefit analysis of whether we use fossil fuels or renewables. It's actually the environmental cost, which is a big problem. We have not effectively dealt with disposal of waste products to warrant what it's essentially doing is just trading off the cost of burning off fossil fuels to provide electricity for toxicity in the environment with real poisons that damage plant life and get into the water supply, And all of those problems, you've got to trade off which is worse, carbon dioxide in the atmosphere or poisons in our environment. And that opens the whole can of worms, of course, into whether carbon dioxide itself is a problem in the environment or not.
So it seems, and I've been looking at quite a few different videos and so on about alternatives that are potentially viable, and I will put up some links and things at the end of this video as well. But I was just looking at a quote from JP Morgan that said, if we can't put a meter on it, we don't want it. So how is our current energy being controlled?
Well, it kind of started with JP Morgan. He had a copper mine and he wanted to take advantage of copper, which wasn't used in major production at the time. And he figured that if he could use it to make a profit, he would. So he was basically deciding that everything should be metered because he gets to install all his wiring. Now that came about at the time of Tesla, who developed the idea of wireless transmission of power, which sounded like a really good idea, but the problem is efficiency with that. And the other problem, not that I'm in any way, shape or form supportive of JP Morgan, but in retrospect, I think it's almost a blessing in disguise that he decided to do that, because we don't really know exactly what kind of health effects Tesla's idea might have produced, because it never got off the ground. But we know from other distribution of electromagnetic frequencies that they're very damaging to life. And there might have been an inadvertent consequence of Tesla if he got his way and had wireless power transmission. It might have caused all sorts of problems. But it largely came down to a profit motive. That's really why JP Morgan wanted to put a meter on everything. And even though we sort of have the ability to have decentralized power at this point in history, I don't think companies really want to lose their control over the monopoly on power.
Yeah, for sure. And speaking of meters, slightly different kind of meter, smart meters. Talk to us about smart meters.
Well, they're a horrible idea for so many reasons. Great for the people who want to control energy use and a host of other things they would like to control. This really has come out of a desire to yet again control everything that we do. The smart meters work on an idea of daisy chaining transmission from one device in one household to another, so that they don't have to wire these things up. Now, they could have done it differently if they chose to. They could have sent the data from the smart meters along copper lines, because the copper lines already exist. Copper lines for the telephones have been adapted for broadband. They could have quite easily tapped into those lines and sent signals directly instead of wirelessly. Wirelessly is cheap and easy for them, but as we know, Wi-Fi is a problem. The fields jumping out of these devices are far higher than safety standards, and you don't really have much of a choice in how you can protect yourself from those frequencies. So basically everywhere you've got these smart meters, you've got a field of at least 30 meters, at least, that is outside of the safety limits. So we're in a soup of transmission constantly.
Yeah.
And it's quite alarming to see the amount of health effects that have been noticed by people, the correlation between installation and switching on of smart meters, and suddenly they're not feeling so well. And it's not just one or two here and there, it's actually quite an alarming number of people that have noticed this. I know people myself.
Yeah. And especially when, you know, in some cases you've got a smart meter literally less than a meter away from somebody's bed. If it's on the other side of their wall, like that's, you just don't want that kind of tech around you. So how is the climate change narrative being designed to keep us bound?
In terms of energy, well, I think that one's fairly self-explanatory, that we're told that we've got environmental problems with our current forms of energy production, and that the only alternative is to either be taxed through the nose via carbon taxes, which all that simply does is transfer wealth to wealthy people and make them more wealthy, or limit what we can use and consume. And the problem with a lot of the proposed solutions to energy consumption are there's always a trade-off. Even when it comes to fluorescent light bulbs, if you look at the breakdown of what a fluorescent or LED light bulb is produced with, as in comparison to an incandescent old school light bulb. An old school light bulb, the incandescent variety, are completely 100% recyclable, and they use very small amounts of materials, versus the promise of the LED light bulb, which the claim is that they'll last 20 to 30 years, and the reality is you're lucky to get 5 to 10 years out of them. All of the electronics that's inside of those, they use lead, certain elements of mercury. In other words, you look at it all, and then no part of the LED or fluorescent bulbs are actually recyclable. They contain toxins. They use a lot of resources to produce. And it doesn't matter what you look at, with possibly the exception of LED television screens. They do use less power, and there doesn't seem to be any negative health effects from those. But apart from that, pretty much every technology I have seen so far that is supposed to deal with this increase of energy consumption always has a negative trade-off. And in my opinion, I don't think that those offset against the supposed environmental impacts are actually valid arguments. It's one of the most divisive topics around, although probably at the moment it's been surpassed by the debates about corona and whether it's real, what it is, etc. Global warming has been the new religion, as far as I'm concerned, that has been created for the world. We've moved beyond conventional religions, and it's being replaced by scientism. And we already know enough to know that the scientific body, I wouldn't call it individual scientists, I think they're doing what they believe is correct, and they believe in what they're looking at. The problem comes from, once again, a top-down problem of control of information.
Yeah.
And although there are political and financial motivations for some scientists deliberately ignoring reality, and the reality being that those who have seen that there is something wrong with the picture we're being painted about climate change, which originally was painted as global warming, and now that's not convenient because the most reliable data is showing that stopped in 1998. And we're on a decline. In fact, in the 1980s and 70s, scientists were actually concerned that the world would enter into a cooling period, another mini ice age in the coming decades. And we're starting to see the beginning of that. But it all comes back to who are the controlling bodies of the data that is used to convince everybody that climate change is A, happening in terms of global warming, and B, that it's caused by carbon dioxide, and C, that it's all our fault. When you break that data down and stop just listening to the repeated and tired rhetoric that simply carbon dioxide is a greenhouse gas, and it's our fault that it's being released en masse into the environment. When you stop just listening to largely reporters telling us this, because it is largely just reporters, and you listen to scientists that are actually saying to you, no, that's not true. Carbon dioxide is not the problem, never has been, never will be. And listen to their data, because, you know, there was a time when I thought, because it wasn't so publicized, that maybe there was a reality to it, that it was being squashed, that maybe we were actually causing this problem, and that the reporters didn't want to tell us. So I started looking, and then when it started to gain very quick traction in the media, which was around about 10 years ago, I think it might have been a little bit earlier, but it was around there. Suddenly this all changed. Suddenly all the mainstream was talking about it, like it was the new big thing that we all had to focus our attention on. And I thought, okay, this is getting a little confusing. What's going on here? So I started digging around for anybody that could definitively explain why it's our fault and that it's carbon dioxide. And all I literally have not found one credible documentary or report or presentation by any scientist who can give me credible information. And all I have seen is many scientists, and the number of them are growing, doing long, lengthy presentations that would put most people to sleep, that show definitively that it is not a problem, that is not something that is under any human's control, for a start, that carbon dioxide is not the cause of global warming or cooling, and that it has been a complete and utter farce of manipulating data to suit an agenda. And I still, to this day, have never seen any scientist talking sensibly or credibly in scientific terms. They'll talk in layman's terms and just keep repeating the same thing, but they won't show any real data to back it up. The data that they have used to back up this claim has already been proven to be false. This was the famous Manly Man's hockey stick argument, where basically what he did is he got two completely data sets, stitched them together and said, look at our graph. Isn't it impressive? The climate is changing because of global warming due to carbon dioxide. He was taken to court and sued, and he lost for fraud. So it has been fraud. Now, there is an actual website that was released at least 10 years ago that actually has the signatures of over 30,000 different scientists from various backgrounds that are related to climatology. And they've all signed to say this is a complete fraud and a farce. And people say, oh, yes, but they're not climate scientists. But the problem there is no such thing as a, in quotes, climate scientist. That's only that actual title has only been developed in the last decade. Prior to that, they were known as meteorologists. And they had to have very vast studies to actually be able to do that. It was not just the study of climate. They had to understand geology. They had to understand solar patterns and cycles. They had to understand a whole slew of various scientific fields. And there are a lot of these meteorologists that are saying it's a fraud. There are geologists that are saying it's a fraud. There are oceanographers who are saying it's a fraud. There are astrologers who are saying it's a fraud. The list goes on, and none of that gets talked about. They keep repeating the 97% consensus. And if you actually look at the background of what that consensus supposedly came from, that itself came from a fraud. It's one of the most aggravating topics for me because it is so widespread, and it really has become a religion. It is the religion of climate alarmism. Start digging, folks, because we're all being lied to, and it's not for our benefit. And this is the problem. These sort of cover-ups of real information are only going to lead to our demise, not saving us. Even though it's under the pretense that we need to stop this to save ourselves, the truth is no, we actually need to stop being lied to save ourselves. It's quite the opposite.
And you don't need to dig even too far at the moment. Like I saw just a Greg Braden video a couple of weeks ago where he was talking about the shifting in climate. And so using the ice, they were determining that the cycles of global warming and global cooling have been going on for longer than we can imagine, and that the cycle we're in is well within the natural shifts that happen as the sun's cycles, as the earth cycles move closer to the sun and away from the sun, and that it's not that the environment or the globe isn't warming, it's that it's not abnormal compared to the larger cycles. And so he's saying it this whole narrative, as you say, around global warming that's being caused by us is a complete farce. But at the same time, I feel like it's important to just separate a couple of conversations, because we've got the whole idea of global warming versus environmental change. And I feel like part of the duality of this conversation is a lot of people will call climate denialists people that are just going to trash the planet. And we're not talking about that. And I think it's important to state that we're not talking about that. Yes, we've got a planet that is just filthy with the trash that we are generating, but it's not because of global warming that we need to shift our habits. It's not out of the fear of killing our beautiful Mama Earth off. It's out of the love for her and just to clean her up that we can do better. So I just feel like that's an important point to put in there. Just because global warming is a farce doesn't mean we can just continue trashing her. That is not it at all.
Absolutely.
Yeah.
You know, no one wants to live in a polluted planet. It affects us all. It affects all life, which affects us. It's unpleasant to look at, even just from an aesthetic point of view. It's bloody ugly to see trash floating down the river. It affects the sea life. It affects life everywhere. And nobody wants to live in a filthy planet. And if it truly was, if the supposed climate change was really the biggest problem, everybody would be looking at this and going, well, let's just fix this. But too many physicists and scientists know that it's a farce, and the things that are the problems: pollution, toxicity, being blanketed with EMFs, being crammed into smaller and tighter little smart cities, and all of these things. These are the real problems. Climate change is the last thing that is A, something that we can even do anything about, and B, that is even a real problem. I mean, the climate has changed historically. It never will stop changing. Doesn't matter if we all died, if the whole human race died out, climate change will still occur. Climate will get warmer. Climate will get colder. It will change, sometimes very dramatically. It's a non-issue. Where it's a multi-trillion-dollar a year industry, wasting everybody's time and energy when we could have been using those trillions of dollars every year to actually clean up the environment properly, to get rid of the real problems. And it's just a diversion from the real issues. And it just kind of makes me wonder what sort of madness is going on in the minds of people that are controlling this sort of agenda. Yeah. Do they want to live in a disgusting soiled planet? Or I can't understand their mentality. It's beyond belief what's going on.
I think Jordan Peterson put it so beautifully when he just said, the best thing that we can do is to make sure that all of the kids are well fed and well educated, because nobody cares if their basic needs have not been met. And, you know, the worst thing that can happen is that you have hundreds or tens of hundreds or thousands of really great brains that have been properly nourished. Then we'll have, you know, we'll have that many more good brains on the planet, one, who care, and two, who might actually have some more great ideas on what we can do. So let's then have a look at some of the possibilities of how things could be better. You mentioned before about using solar hot water in housing. So I know you've spoken about the negative side of solar, but you said that this one is a positive. So why or how is that different?
Well, it's different because part of the problem with solar power is for electricity production is electricity production through solar cells requires, once again, it goes back to resources and the pollution that's created by mining and everything else. Solar cells need a lot of a very pure silicon, and you have to get that from somewhere. You have to process it, mine it. Then you've got the plastics involved, and all of those things. They're also not very efficient. At best, you're going to get about 20% efficiency out of current solar cells. Whereas solar hot water, can convert far more energy directly into heat energy, which of course, when you're using solar energy for production of electricity, you have all of the polluting and problems and difficulties with producing solar cells for electricity production. You need silicon, which has to be a pretty high grade silicon to do it. You've got to process it. Then you've got all the plastic paneling. You've got all the materials that sit in the sun, which break down because of the ultraviolet component of the sun. So they don't last forever. You're going to get about maybe 20 years out of the cells. You've got to look at how much energy is used to produce those cells. Then you've got to look at the efficiency of those solar cells. They don't produce a lot of electricity compared to the energy they're receiving from the sun. At best, you're getting about 20% efficiency. When it comes to solar hot water, it doesn't require all of those materials that can break down. I mean, they do currently, but it's very easy to produce solar hot water with materials that should last you a lifetime. And there's a much higher conversion ratio. So you're better off using solar for your heating options rather than your electricity production options, at least with the current technologies we have.
Yeah. And so when you're talking about solar hot water, rather than having solar cells that are then sending electricity to go to a heater to heat your water, you're talking about your black strips that have the water moving through them specifically, like on rooftops.
Yeah, that's right.
So so the water is receiving that energy directly rather than being sent through external technology, which you're saying is where it reduces its efficiency.
Yeah, that's right.
Yeah. And we know that there's been a lot of experimentation with all sorts of different forms like wind energy, tidal, geothermal, hydroelectricity, all sorts of things. And again, a lot of those you're saying comes back to storage is always going to be the issue. Do you have any comments around how that storage can be actually improved?
There have been a couple of ideas thrown around about how that can be done, but a lot of those ideas have not really been explored to their full potential. For example, one idea was put around that you could basically during the daytime you could, for example, pump water from one place to another, which in a higher elevation, so that during the time when the motor no longer runs, if that's run off solar or wind power or whatever it would be used to convert to pump the water up, then during the periods where you're not receiving that energy, you could use the potential energy from that stored water to produce electricity as it drops again through a pump or a generator. A lot of the non-polluting varieties of energy storage have not really been fully explored, which is unfortunate. But when it comes to tech companies that are largely trying to find the solutions to all of these things. They want to do it with a certain mindset. They want to, of course, produce a profit. And a lot of the devices that they're producing in this disposable era don't last for very long. They don't last, certainly not long enough to warrant the expense and cost involved with producing them. And so perhaps people out there have some good ideas that are worth developing that have not been thought of yet. But yeah.
And you did mention solar cells that don't use silicon. They're using the infrared spectrum instead of visible light.
Yeah, like a lot of these ideas that have popped up, they just seem to disappear again just as quickly. I suspect there's political and other motivations for why these things disappear, but there weren't many discussions, I think it was about 8 years ago, that I saw where there was already the ability to produce solar cells that were something like 80% efficient, and because they responded not to the visible light spectrum that current solar cells use, but actually the infrared. And there's a huge amount of energy coming from the sun in the form of infrared energy. That's what heats up the planet and gives us our warmth. And they got it to the point where they were talking about the potential of a type of paint that would be used. So you wouldn't even need to install panels. You could literally paint it on your roof. So that would have been a brilliant option if it were developed further. And even if it wasn't done as a paint, even if it was still panels, we're still talking a massive jump in efficiency, which would warrant the use of those.
Yeah.
But unfortunately, that seems to have largely gone to the wayside. I don't hear any discussion about it in the mainstream or tech companies talking about it. Yeah.
And what about, you mentioned the steam engine that the two guys collaborated on.
Yeah, there were two gentlemen in, I believe it was Canada. I saw this about 12 years ago. One of them had produced a very highly efficient steam engine. It wasn't like like a locomotive style with pistons and all sorts of contraptions going on. It was actually essentially two tubes, one inside the other. The one on the inside had a series of holes punched through it. So it was a very cheap thing to produce. He built it in his garage. And it was an incredibly efficient thing. And it ran off pressurized steam. And he happened to find out that another gentleman in his neighborhood was working on a steam generator that used the difference between a very small temperature change in the environment would be used to, you'd run water through these series of black panels, and they didn't work by directly heating them like the way solar hot water works. They actually worked by the difference between two temperatures. So it actually worked even in cold climates, would actually produce steam just by the difference of the two temperatures. So the two of these guys got together and joined forces, and they came up with a device that would basically power 50 100-watt light bulbs. So that's 5 kilowatts of energy for free, and it would work down to something like I think it was minus 20 degrees centigrade, which is a pretty impressive effort, and it would work day or night.
All right.
So
interesting. What are some of the cool things we've seen in the past? We've been chatting about this over the months because there's some interesting ideas that our history has unfurled, such as the pyramids and so on. What are some of the things in that realm that have interested you?
I've always been fascinated by the pyramids because in terms of structures in ancient Egyptian times, they don't make a lot of sense. At least not from the conventional perspective of archaeology and history. They were considered to be tombs for so long, and still are by the mainstream historians, but that's proven to be completely false. The three main pyramids, the infamous ones in Giza, which reflect a pattern of the constellation Orion, for whatever reason, if you look on the inside of those, anyone who goes there and looks, or just pull up a video, you'll see it. There are no hieroglyphs anywhere. There are no symbols or markings inside those things. And yet you go to any temple and you go to any smaller pyramid that actually was a burial pyramid, there are symbols there, there are hieroglyphs everywhere. But the pyramids are completely, they're devoid of those things. They look more like machines of some description to me. And those who look into the technology that was used to build those things must have been a lot more, let's just say, less primitive than historians would like us to believe. They're incredibly well-engineered constructions. Very exotic and strange. For example, they just happen to be, they can work as capacitors because you've got two different types of stone that are used to build them. And if even conventional physics will verify that those two stones, granite and sandstone, can form an electrical capacitor. They're also built on a type of bedrock that is believed to be located in a place where, when the pyramids were first built, there was actually, it was right along the Nile River.
Yeah.
So you had a lot of water flowing through this bedrock, through lots of little cracks and crevices throughout. And when you start delving into what happens with water when it's flowing in particular ways, you start noticing strange behaviors. I don't know if you've ever done this little experiment, but I learned this when I was a teenager. If you get a very slow but steady stream of water coming out of a tap, very, very thin stream, so it's almost stopped but not quite, and you say get a screwdriver or any sort of metallic object and you start putting it near the stream, just very, very close, you'll start to see the stream bends around its standard pathway, excuse me, of just dropping straight to the ground. Why is that? Why does water do that? Because it's got nothing to do with airflow and using air to bend the flow. It's got nothing to do with that. And it works with things that are not even statically charged. So it's not static electricity that's doing it. Something peculiar is going on there. And although no one has proven this definitively, because of course, how do you restart the flow of water going underneath all the bedrock into those pyramids? Well, that can't be achieved at this point. But I do know that there were reports from people in history. For example, the famous Aleister Crowley did an expedition to ancient Egypt, and he actually climbed the Great Pyramid before you were forbidden to do it, and took up with him a contraption that proved that there was actually a massive amount of electricity, even without the flow of water, that produced such a strong charge it actually flung one of his assistants off the construction.
Really? Wow. Interesting.
So something's going on there.
There's a lot of really interesting ideas and potentials around archaeology, and we've both been reading Max Egan's book in the last chunk of time, and he's got so many different examples of old archaeological finds that are, even in this day and age, impossible. We just don't currently have the technology to be able to generate those objects, and these were found in periods of rock and so on that are potentially millions, if not billions of years old. And so it kind of suggests or speaks to the fact that we have been in a cycle of technology before, and possibly many times. And Matt Belair, I was watching an interview with him on Collective Evolution a while ago, and his background's more as a coach, but he's spent a lot of time with Native Americans that have carried down the traditions of their ancestors for a long time. And a lot of those people speak about different forms of technology that they've received, say, passions or instructions for, such as there was one that a very simple piece of technology, but it generates the frequency. I think, is it 300 hertz that is the same frequency of the Earth?
No, it's a lot lower than that. It's it changes. It's called the Schumann resonance, and it cycles between, I believe the measured cycles in history have been jumping between 7 and 13 cycles a second. It was somewhere around there, and it was pretty low.
Okay, right. Okay, me and electricity, we're not such good friends. But you turn this thing on or plug it in, essentially plug it into the ground, or however it works. He wasn't actually able to share the information of it for obvious reasons. But he said, I know what the 300 was. He said it creates a field that's about 300 meters wide that acts as kind of like an energetic field, that then anything within it, it will reset that back to the frequency of the Earth. So if you're, somewhere, say in a city where you're being bombarded by EMFs and microwaves and Wi-Fi and all of the things, you can plug this thing in and it acts as a shield. And he asked, well, why aren't you making these things and distributing them? And he was told on more than one occasion by more than several different people, just saying, look, if we bring this out, we'll be gone. And so it's really needing that critical mass, and that our entire system of governance, or lack thereof, to change, basically, in order to be able to generate that kind of stuff safely. So we know that the ideas and possibilities are definitely out there. What's your take on nuclear energy?
Nuclear energy is a complete and colossal waste of time and resources, in my opinion. The reason for it is the promise of nuclear energy. What it was, that it was cheap and clean, and of course that's proven to be completely and patently false. Let's start off with the cost-benefit analysis of using nuclear energy. In itself, once these things are established, theoretically, you'll get a great cost-benefit going on. The problem is, if you account all of the energy that's used, and once again, it's going back to oil consumption and coal power, or what other powers that are being used to do the mining, the processing, the building of these enormous structures, dealing with nuclear waste, disposal of nuclear waste, which is a massive, massive problem. When you, just from the fossil fuel consumption, if you took all of the fuel, the coal, the oil, etc., that was used to produce enough materials to produce the nuclear reactors, the disposal of the nuclear material, the processing of the nuclear material, the mining of the nuclear material, you would find you would only get about a 20% improvement. In other words, you would only gain about 20% of the energy out of the nuclear fuel used to produce electricity than if you'd simply taken all of that oil and coal and burnt it to produce the other 80%. In other words, the cost involved with doing it, of course, it makes companies that run these mines, the facilities themselves, etc., it's a great profit for those companies, but the price that you pay for that is all of the waste, not just the nuclear waste, but all the other byproduct waste that's produced, because you've got to use a lot of chemistry, you've got to use a lot of chemicals, using tons and tons and tons of concrete, and the list goes on of the environmental problems associated with nuclear power. You've got the disaster, the Chernobyl disaster, you've got the Fukushima disaster, which is still going on. That is one of the most devastating nuclear events, and it's just one of potentials on the long list of nuclear facilities around the world. It's a colossal waste of our time. All of that time and energy should have been spent on actually getting into the real technologies which would truly change the world for the better. And that is, of course, the ridiculed and scoffed at idea of free energy, which, if people really spent any time looking into, would realize, and that includes the scientific community, and some of them have actually figured it out on their own, that there is a enormous amount of background energy certainly throughout the world, perhaps throughout the entire universe. Many physicists in the past have talked about it under various names. Einstein called it ether space. Many other physicists have talked about it, particularly the physicists whose name has been practically written out of history, like Nikola Tesla, and many others, Morley. There's a list of maybe nearly 20 physicists that have stumbled across this same idea and have done experiments to sometimes to conclusively prove that there is an enormous amount of background energy. They're talking about even quantum physics. They're talking about something like within a cubic centimeter of empty space, there is enough energy to run a submarine to go around the world 3 times. That's the kind of energy we're talking about. The trouble is,
I heard Stephen Greer
how do you get it?
that a centimetre of space could power New York for 3 days or something wild.
And in more recent times, there have been a couple of, some of them qualified physicists, but also a lot of people have figured this out independently and sometimes accidentally, that you can tap into that energy and very cheaply, using devices that would last a lifetime, that don't require much in terms of materials, and at very little low production costs. There's a man by the name of John Searle who spent the last 30 to 40 years working on how to get this technology out to the public. He actually developed this technology, I think it was in the late 70s, using magnets in a special configuration that can tap into that background energy. These machines he's been talking about more recently, he's teamed up with a qualified nuclear physicist who was very skeptical about John Searle for a number of years, and but he sort of, I think he sort of bit the bullet and decided he just wanted, there was something in him that said, yeah, maybe there's some truth to this idea. And after 2 years with John Searle, he realized that it is feasible, that because John Searle was able to explain to him exactly how this technology works. It wasn't just, oh, I found this device and look, it does this weird thing. It was actually, he could explain how it functions. So they've been collaborating, trying to work out how to get these devices onto the market. And of course, that's leading them into all sorts of headaches because of national interests and supposed national security interests, economic concerns, because the economy largely is driven by the cost of oil. I mean, that's what the US dollar is essentially based on, is the price of oil. And what would that do to the market? I mean, it would decimate it essentially. Now, these devices he was talking about, if you think about most of our energy production, it's actually in cars. cars use a crap load of energy compared to what we use in a household. And even one of these small devices that would be approximately 1.5 by 1.5 and maybe 20 centimeters tall, something you could easily put in your boot, would cost about $12,000 but would last a lifetime. Compare that to the cost of how much your petrol costs and how much you would spend over a year. It will pay for itself within 2 or 3 years for most people. And you would, if you had an electric car, that would never expire.
Amazing.
So, yeah. And, this is just one of dozens of technologies that are accessing the same energy. It's just a question of how do you get this to the public, bypassing the movers and shakers who really don't want this technology out there.
Yeah. And there are some people that are on that route of starting to get that technology out. Like there's Susan Manowich from the New Energy Movement in America, and she did a interesting talk with, again, Joe Montano from Collective Evolution. And yeah, their entire business is based around receiving ideas from inventors around different technologies and seeing if they are viable, if they actually do what they say they're going to do. She said about 1 in 100 proposals actually makes its way through their organization. And so that's the New Energy Movement. So that's interesting to look at. But you mentioned somebody else, John Hutchinson, regarding radio transmissions.
Yeah, John Hutchinson has been experimenting, following on from one of the more well-known physicists in history, who was playing around with combining different electromagnetic radiation types. Everything from ultra low frequencies to microwaves, radio, and through trial and error and experimentation has discovered some truly bizarre effects. He's got a website where he's shown a number of videos and which people seem to think have been debunked, but he's actually had independent crews come in with cameras and showing what's going on. And as far as I can tell, it's absolutely real. One video actually shows a block of iron sitting on a wooden table. Now, before I even tell you what happened to this piece of iron, let's talk about what would happen if you tried to melt or bend that piece of iron. It's about 1.5 inches diameter, and it was probably about 12 inches tall. How much energy it would take to either bend it or melt it? We're talking about a hell of a lot of energy. And if it was heated up, it certainly would set the table on fire, because steel melts at, I can't remember the exact figure, but it's something around, well, it's certainly higher than the temperature that kerosene burns at, which is well in excess of, I think, 1,200 degrees. Wood is not going to survive it. And yet we're seeing a video of a block of iron, bending over on a wooden table. It's literally bending over like it was melting. And yet immediately after, he came and picked it up off the table with his bare hand, and it was cold.
Yeah,
and he was doing that.
Bizarre.
Yeah. And of course, that iron becomes incredibly brittle. You can almost snap it in half with your bare hands after that's happened to it.
Yeah.
What's going on there? I mean, it's such a bizarre thing, and I'm really stunned that it's not mainstream knowledge, especially in the scientific community. They should be absolutely boggled by this. It's such a simple thing, but just the fact that frequencies can cause metal to do that is so bizarre in conventional thinking. It should be across the news, and it's not. And he's been doing this for over a decade.
Yeah.
What he has had is many visits from the FBI, because they're very concerned with what he's doing with that.
I'm sure they are.
But the point of showing things like that is to illustrate the lack of knowledge in mainstream scientific communities, and that they really haven't thought beyond what has been largely taught in universities, which of course goes back to control of information and knowledge.
I was going to say they're not allowed
And
to think beyond that, are they?
well, in my opinion, no, they're not. And I don't think even the professors that teach physics are even aware of that situation. I think they're largely oblivious to that their own institutions are essentially controlled externally through various mechanisms that they're not entirely aware even occur. I mean, I don't think, why would you even assume in that world where they spend so much of their life studying and at considerable personal expense financially to achieve degrees and PhDs and master's degrees. I think it would be an enormous challenge to their worldview if that was suddenly challenged with, guess what, guys? There's a whole realm of physics that you're not aware even exist and no one's telling you. I think that would be very difficult to swallow.
Absolutely. Yeah, cool. Thanks for sharing all of that. So yeah, now it really comes down to, well, what can we do? And from what I can see, you know, we are dealing with issues of control. It's not that technology and various options aren't available. It's just finding the ways to be able to do it safely without all of us disappearing in the middle of the night. So I guess what I'd like to share is just some information on what you can do to help, especially from a health perspective right now, dealing with what we currently have. And I'm speaking to this partly because I personally am incredibly sensitive to EMFs and to electricity, and some of my friends who are dealing with chronic illness also have quite severe sensitivities. So I've been following Dr. Dietrich Klinghardt for some time, and he's been working with a lot of chronic and unexplained illness and autism and Lyme disease and all sorts of things for a long time, for over 20 years. And he's working with clients, he's working in the trenches, he's not reflecting on other people's research. So he's really talking from experience. And he pretty much says to parents of, say, kids that are coming in with autism, he will not treat them until they completely clean up the electricity in their house. And so he gets them to go to reasonably extreme levels, which is to cut off the entire electricity to the house itself at night time, because our body, I think it's about 11 till 3, like that's the main time when our body is rebuilding itself and detoxifying and healing itself. And so we really need that time to be clear. So what I do is I actually just turn off all of the power in my bedroom at the power points, so that at least you're not gridlocked by electricity. And, you know, we've spoken before in the communications segment about, you know, turning off all the Wi-Fi, and so I'm not going to go more deeply into that. But I think if it is something that affects you or you're concerned about, it's worthwhile looking into Klinghardt's work. And he also talks about using EMF shielding. So if you look online, you can find things like you can buy canopies that are made of a silver fabric. They look essentially like a mosquito net, but they basically stop EMFs from coming through. And a friend of mine who has Lyme disease bought one, and she was sitting in bed trying to use her phone going, what's going on? Why won't my phone work? And then she realized it's because she was in a canopy. So they work. So, you know, there's different things like that. You can buy clothing that's actually made out of, that has these silver threads through them. You can get you can get or make, if I'm just going to buy some silver fabric and make things like a cover to put over the Wi-Fi router, and you can buy bags to put your mobile phones in, all of that kind of stuff. So you can shield yourself from EMFs. I've also got a grounding sheet that I have on my bed, and also a grounding mat that I put under my feet when I'm working at the computer. And they plug into the power socket on the wall, but they just plug into the grounding point. So it's essentially earthing yourself while you're sleeping and while you're working. And I find that that helps hugely. Part of the reason that I love camping is just being in contact with the earth. So I find these days, if I'm feeling sick, one of the first things I'll do is just go and actually put my bare feet on the earth, go down to the ocean if I need to, and just to shed that excess electricity from my body. So I find that that's absolutely necessary. And just educating ourselves about these different options, and I think is just so important. Not only what other kinds of technologies are available, but just things like learning homesteading, like learning how to cook if all of a sudden our electricity gets cut off, where we've put ourselves in an incredibly vulnerable situation, or we've been put in a vulnerable situation, however you want to look at it, where most of the things that we require for our living, we need money, and we need a government, and we need all of that massive infrastructure able to be able to bring us our water and our gas and our electricity. So even just the simplest thing, learn how to rub some sticks together and make fire, learn how to make a water filter so that you can get water out of the ocean. You know, just those absolutely basic things that might seem ridiculous. But if at any stage the systems broke down and we found ourselves unable to do our day-to-day tasks, we might be thankful that we spent a bit of time hanging out with the hippies in the bush. Which brings us then into what can we dream? And we can dream so many things, and we don't even need to dream that far, because, you know, we already see that there are constantly new ideas, new movements, new developments happening all over the world that are doing things better a bit at a time. And I watched the 2040 Vision movie about a year ago, and that was great because, you know, they were chatting about different things that people are doing and talking about things like decentralizing electricity. And we already know that the issues that you've spoken about with that are still there, but just the fact that people are taking steps towards these things, and therefore more people are being aware of them, I think in the long term can only help to move us forwards. And, you know, the things like sustainability as a subject has been taught in Australian universities. I know that has been taught over in Western Australia at Murdoch for at least 10 years, if not more. So that idea around thinking sustainably, about seeing the idea that one person's trash is another person's treasure, of starting to get in touch with the way that nature does things. Like, nature doesn't leave any trash behind. You know, she automatically sets up these systems of renewal. And so I am seeing more and more ways that people are seeing that and translating that into manufacturing, you know, into things like looking at social enterprise, and looking at all your supply chains, and just making sure that all of those suppliers are using renewable sources. Things like clothing manufacturers that now, part of their selling point is the fact that they're sharing very detailed information on how to take care of your clothes so that they last a really long time, and that, you know, they have a repair service, and that they have a recycling service and things like that. So it's starting to become a marketing point for businesses to be more aware of their resources, and that's happening because the public are demanding it. And so that's where our power as consumers comes from, us becoming more participatory in that by demanding that things are just done better. And I've been talking for a while about looking at business with the viewpoint of that the earth is one of the stakeholders in it, which helps to ensure that the decision making that happens in those business projects are also going to be in service to the earth. And so I think that those kinds of shifts in thinking are definitely going to steer us in the right direction to make sure that all creatures prosper. So what's in your dream, Mars? What can you see happening in the future?
Well, I think that in the long term, it's going to become inevitable that these technologies that can truly liberate us will, one way or another, come out. And whether that's from a grassroots movement, or perhaps there will be a shift in thinking by necessity through governments in future. I think the days of mass consumerism are largely going to end, and the world that could come about from, if such a simple technology as this abundant free energy was to become available to us, even if it was not on a personal level, in other words, a device in every home, but even if it was still using the grid, but it was powered by patented hidden technology, unlimited energy would change everything for us worldwide. It would change absolutely everything. The limitations that we have by the fact that fuel costs money, if that was eliminated, the cost of all production would be dramatically reduced. The solutions, such simple things as the availability of fresh water. With free energy, that would mean you could turn the entirety of this country, which is a huge landmass, into a forest. That could feed the entire world. You could transport food to every part of the globe for effectively the cost of paying someone to navigate a ship. The production of minerals and doing things sustainably and recyclable. The cost of recycling materials is largely controlled by how much energy it costs to recycle things. If the energy component was no longer an issue, if you think about in other words, the daisy chain of things that could be done differently just by having unlimited free energy would change absolutely everything for the better. It would be extraordinary what could come about that. It would mean the end of excuses for wars over resources. That would be gone. It would mean unlimited travel. It mean if you really think about it, it'd be like living in the Jetsons and beyond. It would be absolutely extraordinary.
It would be the end of third world countries. They just wouldn't need to exist anymore because they could be self-reliant. Yeah.
That's 2/3 of the world population that are still in survival mode. That all those minds that could be put to work to create solutions and to think about things in a very different way. It would be incredible. It would be absolutely incredible.
Yeah, absolutely. I agree. I'm seeing it. I'm just seeing the level of technology that could be available. And once, I don't think we can go backwards with technology, but I see that using I saw on a Netflix series not a little while ago, it was a design series, and there was a woman who was looking at like how different things grow, like molds and like kombucha cultures and all sorts of different things. And she was basically growing art. And so, you know, they were talking about the fact that they're shifting from nature inspired art and moving instead towards art inspired nature. So working with nature to enable the growing of all of these things. And I feel like that the idea of technology with nature will start to gel and combine. And you know, I had some ideas come through a few days ago about being able to tune into the way that trees communicate with each other, about the way that water holds information and doesn't even just hold information in itself, but the fact that water tunes into the field of information around it, again, which was inspired by one of Greg Braden's videos. And the fact that we will at some stage be able to tune into that same level of information storage and speed of communication without necessarily needing to generate man-made structures, that we eventually will learn how to tune into how nature already does an incredibly advanced technology. We just don't see it because we don't know how to access it yet. So I feel that that is going to be a huge step forward as well. It's just like another sense required, and we don't know how to use that sense yet, so we don't have the interface for it. And so I guess that's moving into how we evolve as a humanity rather than what we generate outside of ourselves to then be able to interface with those different things. But look, I see the possibilities being endless. I just see the end of our industrial areas and our smelly, stinky factory areas, and that we can do everything cleanly, and that we don't have to have people around the world dying in hideous, toxic environments in order to be able to give us our 5-cent plastic lunch boxes. So good stuff, good stuff. All right, well, thanks so much for being here today, Mars. Is there anything else that you would like to add before we head off?
Oh, I think if I added anything more, it would just open a whole new can of worms. So I think I'll just say, yeah, spend a little bit of time, and if anything, I would really love it if people were still concerned about, particularly the climate change fiasco. Please, please, please start listening to some alternative views from credible scientists, because that is a big concern. They need public belief in that situation, and without our belief in it, they can't really move forward.
Have you got any suggestions of any worthwhile sources of information along those lines?
Well, there are a number of various scientists who have talked about it publicly. How I found them was really just looking through videos and searching for, well, the easiest way to find any of them is climate change scam, or any terms associated with an alternative opinion. You'll very quickly find them. I can't remember the gentleman's name right off the top of my head. I think it was Poppenbeek, his last name. He was in a Senate hearing some years back, and he provided an enormous amount of data and information for the Senate, and that's an important one, because that would, if he was lying, he could be held up for perjury, and he was still willing to say everything that he said. That's an important thing to remember. The setting in which people give testimony is very important, because if a public official, especially in America, is caught lying, they can face 10 years jail and $100,000 fines.
Yeah.
So if they're willing to stand up and say it with that threat, you know that they might have something important to say.
Yeah.
Mm.
So do your homework.
Mm-hmm.
Awesome.
Yeah.
Thank you for that. Always a fascinating chat. And
thank you.
I think next time up, we're talking technology again. A different part of technology. Today was about energy. I think next time we might be chatting communication or transport or something, whatever it will be. It will be fabulous.
Great.
So, all right. Thanks, Mars. I'll catch you later.
Thank you, Tony.
So that's all from us today. Thank you so much for watching. If you've got any questions, comments, ideas, please feel free to send me an email, info@in-spiral.org. And yeah, until next time, my friends, stay well and keep dreaming the good dream. Ciao for now.